Hello everyone, welcome to the channel Code Like Him. Let's see today's problem, the painter's partition problem 2. So we are given an array where each element denotes the length of the board and an integer k representing the number of painters available. Each painter takes 1 unit of time to paint 1 unit length of board. Determine the minimum amount of time required to paint all the boards under the constraint that each painter can paint only a contiguous sequence of boards, no skipping or no splitting allowed. So in this question we are given an array which denotes the length of the board, which denotes the boards, and each element of this denotes the length of the board, and we are given an integer k which denotes the number of painters available. We need to paint all these boards with these painters such that the time required will be minimum, and there is a condition between condition that a painter can paint only contiguous sequence of boards. So if a painters let's see this example, we have boards 5, 10, 30, 20 and 15, and painters available is 3. So answer will be 35. So the optimal configuration will be the first painter paints 5 and 10th board, so the time required to paint this board will be 15, because 1 unit of length will be painted at 1 unit of time. So the time will be 5 plus 10 is 15. The painter 2 can paint this board 30, which will be all in 30, so time required will be 30. And the last painter, the third painter, can paint these two boards, so time required will be 35. So the maximum time required to paint all the boards will be this 35, because job will be done when all the painter finish. So let's say at 0 unit of time painter 1 starts, at 0 unit of time painter 2 starts, at 0 unit of time painter 3 starts. So the painter 3 will be the last among all these painters, because it will take 35 seconds, 35 unit of time. So the minimum amount of time required to paint all the boards will be 35. So answer will be 35. So from this question, what we can see is we can see that we can find a range between we can find a range, and then we can check, we can find the mid, and then we can check if this amount of time, at this amount of time, the required the painters we have, can they finish the job or not. For example, let's see, and we can use binary search to increment or decrement that range. Let's see the code here. We will initialize low by 1, because 1 unit will be required at least, and high will be by 0, and the high will be the sum of all the units of this board. Because let's if one painter will paint all the boards, then the high will be the sum of the elements of array. And then we will iterate over this, we will check if this mid, which will be low plus high minus low by 2, if by this mid it is possible to paint all the boards or not with k painters. If it is possible, then result will be minimum of previous result and the current mid. And then we will increment, and then we will decrement the range, because we need to find the minimum. So we'll decrement the range, we will move towards the left half. So high will be mid minus 1. If it is not possible to paint all the boards with the k painters, then we will move towards the right range. The low will be mid plus 1, and then we will return result. So let's check if is possible function. We will take t time, and we will take array and n, which is length, and k painters. So current time will be 0, because starting with initialize current time will be 0, and required painters will be 1, because at least we require one painter to paint the boards. We will iterate if any point of time the array of I, which means this, is greater than time t. We will simply return false, because if with one painter we cannot paint this board with this t time, because it is greater than our t, so it will be returned false. Then we will increment this current time required to paint by the painter with the area of I, and if this current time is greater than t, we will be requiring more painters, because one painter cannot take more than t time. So we will be requiring more painters. We will increment this required painters variable, and current time will be initialized to this array time. and at any point of time is requirement is greater than k, we will simply return false. If if this loop runs perfectly, then we will return true. So this is a simple approach using binary search. Guys, if you like this video, please subscribe to the channel and like this video. Thanks.